Okay, I'm back. Let's continue. I don't remember exactly what word I was at when I got cut off, but we're now going to subtract these two equations to cancel out our z's. So 6y minus a negative y is 7y. Negative 3z minus a negative 3z is 0. 21 minus 0 is 21. Divide by 7, so y equals 3. So now that we know that y equals 3, we can actually go a couple directions here. So first, I can go back to where we saw in the beginning, x minus y was 5. So if x minus y was 5, then x minus 3 equals 5. Add 3 to both sides, x equals 8. I can also go to either one of these equations we found. I'm going to pick the one without the negative y, just because, I guess. So 2y minus z is negative 7. So then 2 times 3 minus z is negative 7. 6 minus z is negative 7. See, I did something weird. Figured it out. It's just like in class, right? Where I make mistakes and we find them and it's kind of annoying, but we deal with it, right? So the mistake I made was negative 7 times 3 is negative 21. So I have negative 21 minus 0 is negative 21. Negative 21 over 7 is negative 3. So then if we go back, now I know that if x minus y equals 5, x minus negative 3 equals 5. X plus 3 equals 5. X equals 2. That's better. Now I can use one of our equations again. I'll use 2y minus z equals negative 7 like I was going to before. So 2 times negative 3 minus z is negative 7. Negative 6 minus z is negative 7. Add 6. Negative z is negative 1 times negative 1 divide by negative 1. Z is 1. So for this one, our coordinate trio is 2, negative 3, 1. And again, the big thing here is I don't want to say infinite ways because there probably isn't, but there's a lot of different ways to solve these, and I don't care which one you use.